This is the second video in the trigonometry topic of the Pure Maths 1 course on the sine rule, and in it I'll be looking at the ambiguous case. Okay, let's consider a triangle ABC with side AB equals 6 centimeters, BC equals 5 centimeters, and the angle A equals 38 degrees. And we want to find angle C. Okay, well, I'm going to try and construct this triangle. Okay, so I have a line here, and I've got a ruler which is inclined at angle 38. We can see 38 degrees there. And I'm going to place the ruler here at that end of the line and measure 6 centimeters to there and draw a line. Oops. Okay, just tidy that up a little bit, and we see here we have a line of length 6 centimeters and at 38 degrees to the horizontal there. So this is the point A down there. So and this is B up here. Now I want to draw a line BC so that the length of B from B to the horizontal line is 5 centimeters. And the way I can do that is if I draw a circle of radius 5 centimeters and center B, I can find where the circle intersects the dotted line. Okay, so I've got my pair of compasses and my ruler, and I'm going to have a radius of 5, like that. Move the ruler out of the way and then draw a circle centre B, like that. Move the compasses out of the way. Okay, well, I'll just make the circle here green, a dotted line, and we can see where the circle cuts the horizontal line here. We can see it cuts it at 2 points, which means there are 2 possible ways we can have, or positions of C, so that BC equals 5. We can either draw BC like this, or we could draw BC like this. Both these lines are radiuses of the circle, so they're both of length 5 centimeters, and so both would give us a triangle ABC with lengths 6, 5, and with angle 38. Okay, just starting up like that. So we have 2 possible positions for C, either here, which we can call, say, C1, or here, C2. And the third length, AC, could either be AC1, which is this longer length, or this length here, AC2. So either this first triangle on the left here, where you can see we have AB 6, BC here 5, and the angle A is 38, and so we have here is AC1, we have that length, so we have that triangle. Or we could have it in this configuration on the right. AB is still 6, angle A is 38, and we have the side AC2, BC2 is 5 centimeters. Both of these triangles, which are different triangles, have the same specification, AB6, BC5, and angle A 38. So the question is, what is angle C? So this angle here, or this angle here? This here, or here? And we can clearly see that they're different. In the first case, on the left here, the angle is clearly less than 90, and in the second case, on the right, the angle there is clearly more than 90, an obtuse angle. So what will happen if we try and find them using the sine rule? Now, as we found in the last video, the sine rule is sine A over A equals sine B over B equals sine C over C. So let's first of all apply it to the first case, this triangle here on the left. We'll call that number 1, and the one on the right number 2. So for case 1, we're trying to find angle C, so sine C over C, and C is of course the opposite side, 6, equals, we have sine A and the opposite side 5, so we have sine of 38 over 5. This will give us sine C equals 6 over 5 sine 38, which will give us C, if we by using the calculator, angle C will equal 47.6 degrees. Now if we apply the same process to the second case, we again have sine C over 6, that will be sine C2 over 6, equals sine A, which is sine 38 over 5. So we would again get sine C is 6 over 5 times sine 38, and the angle C would be 47.6. Well, looking at the two triangles, we can see in the first triangle 47.6 is a valid angle for C. It's less than 90, but clearly in the second case it isn't. In the second case we have an angle greater than 90. So what is this angle? Now sine C, 6 over 5 sine 38, comes to about 0.739, which gave us C equals 47.6. Well, what does that mean, 0.739? This is the graph of sine x between 0 and 360 degrees. Now the sine of our angle C is 0.739. The maximum point of sine is 1, as we know, and the minimum point down there is -1. So 0.739 lies between 0 and 1, about there. So if I draw a horizontal line across, like that, we can see that at two places on the two values of x give me the sine of x 0.739, either either this value here or this value here. There are further values over here, and no doubt and other values in the, on the negative side, but between 0 and 360 there are these two values here, and these are between 0 and 180. So the first of these values here is 47.6, and the second of the values, well, because of the symmetry, this value here will be 180 minus 47.6, and 180 minus 47.6 is 132.4. 132.4. So we can see that there are, in fact, so there are two values of C, two values for which the sine of an angle is 0.739, 47.6 and 132.4. Okay, so in the first case here, this angle there is 47.6, and in the second triangle here, this angle here is 132.4. So that is that there, and that's a 38 there. And so, knowing two sides, 6 and 5, and an angle 38 which is opposite to one of the sides, is not enough information to know the triangle, because there is two possible triangles that will match that specification, as we have seen. Now, this doesn't always give us two triangles. Supposing instead of having AB equal to 6, we have AB equal to 3. This would give us sine C over 3 equals sine 38 over 5, just by replacing the 6 centimetres of AB with 3 instead of 6 as we had in the original case. Now, if we now solve this equation for C, so sine C is 3 over 5 sine 38, and C would be 21.8 degrees. Now, this would make this would be okay in the first triangle here. Instead of 47.6, we would have 21.8. But if we apply the same rules to the second triangle here, we will find C should be 180 minus 21.8, which is 158.2. The problem with that is we already have one triangle of 38, one angle of 38. If we then have another angle of 158.2, if we add those two angles up, we get 196.2 degrees. So our two angles of the triangle would add up to 196.2. Well, it's impossible to have a triangle whose total angles is more than 180, therefore this is not a possibility. And in fact, what would happen if we tried to draw the circle, if B was here, we would have the circle would cut the dotted line at one point there, but it would not. It would cut it at the other side of A. This bit of the circle wouldn't be able to cut the line again to the right of A, and so there would only be one triangle. Okay, now pause the video and try this question on your own. When you've done it, resume the video and see how I do the solution. So first of all, we would draw a triangle. Side AB is 15, angle A is 54, BC is 13, but there is a further possibility for BC like this, and therefore two possible values for points for C, here and here, and two possible angles there and there for C. So applying the sine rule, two possible values for B. B could be 180 minus 54 minus 111, which is 15 degrees. So that's 15 up there. Or in the triangle with C1, B could be 180 minus 54 minus 69, which is equal to 57 degrees. So this angle in there is 57 degrees. We now need to find side AC. There's two possible cases. For AC2, we would use the sine rule again and say AC2 over sine of 15 degrees, because it's 15 in the smaller triangle, is equal to sine, so 13 over sine 54. So AC2 equals 13 sine 15 over sine 54 by rearranging, which equals 4.16 centimeters. And for the larger triangle, AC1 divided by sine 57 degrees is also equal to 13 over sine 54, and rearranging that equation, AC1 is 13 sine 57 over sine 54, giving AC1 equal 13.5 centimeters to one decimal place. So that ends this video on the ambiguous case of the sine rule. Now return to Study Smart to practice some more problems.